Call or visit aeroservices.com today and get green with Aero Environmental Services Lawn and Shrub Care.
The Earth often seems like it is a nice little closed system. Sure, we get the energy from the sun, but everything affecting it is within the atmosphere. That is not exactly true. The sun is also spewing a constant stream of charged particles that slam into the magnetic field of our planet, altering its shape. This is just part of what we call space weather. For the big question of this episode, we're going to be asking Dr. Nigel Meredith from the British Antarctic Survey, what is space weather and how does it affect us? Would you mind starting by introducing yourself and telling us what you do?
Okay, my name is Nigel Meredith. I'm a space weather research scientist at the British Antarctic Survey. I develop models, global models of plasma waves in space, which are ultimately fed into our radiation belt models, which are also used for forecasting the space weather environment in near-Earth space. And I'm also interested in calculating worst-case scenarios. So, for example, I've worked out the 1 in 10, 1 in 50, and 1 in 100-year space weather event for various orbits around the Earth.
That is very, very interesting. Shall we start by discussing what do we mean by space weather?
Well, the term space weather refers to variable conditions on the sun that can basically influence the performance of technology both in space and on Earth. The main source of space weather is the sun. Mm-hmm. We have explosions on the surface of the sun. They send out bursts of charged particles and magnetic field into space. And when they reach the Earth, they can tear open the geomagnetic field, giving rise to a geomagnetic storm. Mm-hmm. And this can cause disruption to satellites, to communication and navigation signals, to aviation, and also to power supplies. The nature of this risk is such that severe space weather was added to the UK National Risk Register back in 2012.
Cool. So it's something that can be extremely dangerous. How do you monitor that? Both in general, if you monitor in space, but also you specifically, where do you get the data to keep an eye on the sun and how the magnetic sphere around the Earth is changing?
Okay, well, there are various monitors. There are monitors at the so-called L1 point, which is outside of the Earth's magnetosphere towards the sun, and that measures conditions in the solar wind. And then, of course, we have data from satellites themselves in situ in the Earth's magnetosphere, where satellites orbit. And then we can also make measurements on the ground as well. Mm-hmm. So we make measurements of the waves in space on the ground, and also electrical currents that are caused by the aurora. We can detect these on the ground as well, and that's where the Antarctic comes in. So, for example, one of the main threats to satellites are so-called killer electrons. Mm-hmm. Now, these electrons have energies of the order of a mega electron volt, which means they're traveling at a very high fraction of the speed of light. And these relativistic electrons, they can penetrate satellite surfaces and embed themselves in insulators and ungrounded conductors, and here the charge can build up. So the charge builds up, the electric fields get stronger, and eventually they can reach levels which can cause breakdown. And this leads, if you like, to a spark, which isn't good news for electronic components. And sometimes the effects are relatively minor, but sometimes, occasionally, very rarely, an entire satellite can be lost if this happens in the wrong place. So we build models here at BAS of the space weather environment, taking into account the plasma waves in space. Now, these waves have been, one particular type of wave called chorus has been shown, or we've shown that it's important for accelerating these electrons to high energies. We can measure these both in space and on the ground. And this is where Halley comes in. We have a VLF receiver at Halley, which detects the very low frequency radio waves from the chorus emissions. And we use them to help us study the effects of space weather on the radiation environment, and also any potential links with linking space weather to climate change, and also for lightning detection.
Wow, that's it's amazing, and you're doing all of that from Antarctica.
So the VLF receiver is in the Antarctic. There's also a SuperDARN radar, which was in the Antarctic. It's currently in the Falkland Islands.
Okay.
And this radar measures electrical currents in the atmosphere. Basically, what happens during geomagnetic storms, you get these beautiful displays of the aurora, but you also get strong electrical currents which heat the atmosphere and they cause it to expand. And this can slow down satellites and space debris and increase the risk of collisions. Mm-hmm. And this is one of the main uncertainty in kind of orbit prediction models. And so the BAS operates the SuperDARN radar in the Falklands, and it's part of a global network of such radars that can kind of measure and model the heating due to these currents and the effects on space debris and satellites in orbit. So different aspects of space weather. One is the environment itself, and then the other is also it can affect the trajectories of satellites and space debris in low Earth orbit.
That is fascinating. Does all solar activity impact Earth?
When it comes to beating cancer,
the heating due to these currents and the effects on space debris and satellites in orbit. So different aspects of space weather. One is the environment itself, and then the other is also it can affect the trajectories of satellites and space debris in low Earth orbit.
That is fascinating. Does all solar activity impact Earth?
when it comes to beating cancer, your first choice is your best chance. Moffitt Cancer Center brings the highest level of urgency to provide the right diagnosis right away. As Florida's only national comprehensive cancer center, we're fast-tracking therapies and pioneering vaccines while providing individualized treatment plans that lead to outcomes up to 4 times the national average. When an accurate diagnosis and therapy matter, choose Moffitt first. Moffitt, a cancer center like no other.
Summer just got more exciting at Elevate Fun.
Your home, which is why Aero Environmental Services is proud to offer lawn and shrub care services. At Aero Environmental Services, our trained lawn professionals are educated on lawn threats and management techniques and will develop a plan unique to your lawn for ongoing fertilization, pest control, and fungus, disease, and weed control. Let us help keep your lawn and shrubs looking beautiful and healthy year-round. For your free quote, call or visit aeroservices.com today and get green with Aero Environmental Services Lawn and Shrub Care.
Interfere with. So the information is used, and the operators and engineers are always vigilant to possible problems due to space weather.
Okay. Clearly, there are major events that could put a lot of things at risk, but feels that most of probably the stuff that you monitor and model is the least flashy event, let's say, that is the continuous changes in the space weather. How do people use those models to make better choices in both protecting stuff in orbit, but maybe even protecting stuff on Earth at higher latitude?
I think for the satellites on orbit, the great thing about the model and past data sets is that satellite operators and engineers can go back and look at how their satellites have behaved. Or in fact, they probably do it the other way around. They probably look to see when they've got problems. And then they can say, oh, actually, on this day, we had a particular problem with our satellite. And then they can go and have a look at the space weather conditions on that day. And we call that post-event analysis. So all this information is there. The model results are there. The great thing about the model is that it models the whole radiation environment, whereas, of course, we've just got spot measurements from particular satellites. And so this information they can use, and it's statistical. It's not always obvious that an event has been caused by space weather, for example. There could be other factors, just age or just degrading for other reasons, or even a small impact. They might have a database of anomalies, which they could then compare with the space weather environment, and they then get confidence. So they can think, actually, if we get this kind of condition again, this might happen. Of course, it's not a one-to-one correspondence, because as I've mentioned earlier, these charges build up over time.
Yeah.
So it's a bit like the straw that broke the camel's back. You can have a big storm and it can build up and nothing can happen. And then maybe something, rather benign happens, but it's just enough to make that electric field exceed the breakdown levels. So it is challenging.
I can't imagine. All right, to conclude, you've done a lot of interesting public outreach, even turning space weather into sounds. Can you tell us a bit about that?
Yeah, that's right. The amazing thing about the VLF signals that we detect at Halley is that they are actually in the audio frequency range. So they're in the frequency range from about 10 hertz to 10 kilohertz, which is exactly the same as the sounds that we hear. Now, of course, the radio waves that we detect, they're radio waves, not sound waves, but we can convert them directly into sound and then play them back through loudspeakers. So we get to experience, if you like, some of the space weather environment through our own ears. And it turns out that the sounds are quite remarkable. The chorus wave is actually so called chorus because when you convert it to sound, it resembles the twittering of birds in the dawn chorus. And you have a beautiful cacophony, all kinds of variations. So these waves, every time they sound different. And they are some just totally incredible sounds. And then these waves, which you detect on Earth at Halley, they can also be detected directly in situ, if you like, in space, where they're generated. And so when you detect them on Earth, you've got a lot of crackling in the background. And the crackling comes from lightning, because every time you have a lightning flash, it gives out a massive pulse of radio waves, some in the VLF range. So you continually hear crackling on Earth.
From other parts of the world?
Yes, this is what's incredible.
That's fascinating.
So this is totally amazing as well. The signals, the kind of crackles that we hear at Halley typically come from the Amazon and Congo basins, both of which are over 8,000 kilometers away. So these signals have traveled all the way from the Amazon or Congo basins, and then they sound as crackles, and they kind of pollute, if you like, the chorus sounds. And another amazing signal actually comes from the lightning, because some of the radio waves from lightning leak out into space, and then they travel along the Earth's magnetic field line, if you like, and then they're collected in the other hemisphere. And the signals get distorted because the higher frequencies travel faster than the lower frequencies. And so what starts out as like a ping or a crack actually comes back as a whistling sound, a descending tone, like this. And we call that a whistler. So you've got all this activity going on, and it's rather fascinating because it also depends on time of day, whether there's a geomagnetic storm going on. So it's like it has its own kind of symphony, if you like, and it's basically Earth's natural radio.
That is for taking the time to explain all of this incredible science about space weather and how we are turning those models even into sounds.
That's right. You're welcome. Thank you.
Thank you for listening to The Big Questions. Head over to iflscience.com for the latest and greatest science headlines. The music in this episode is credited to audioblocks.com. See you next time.
At Subaru North Orlando, Subaru Lakeshore, 3 times the locations and 3 times the enjoyment. Plus, no hidden fees, and every new Subaru comes with 2 years of complimentary maintenance included. With 3 stores along the 4, the power of finding your next Subaru is in your hands. Visit abuyersbestfriend.com.